It's really impossible to cover all these topics in a one 30-minute presentation, so I hope I will give you an overview, and the speakers that will follow myself will dive deeper into specific aspects of this whole problem, and we will have a panel at the end of the track. So let's start with what is it actually all about. So we are mostly IT people. We are used to being a separate cast of our own for quite a few decades. The IT people used to decide how the company is supposed to run its digital infrastructure. Nowadays, it's all absolutely different. We have new challenges, we have new requirements, and basically we have to adapt, we have to live with that in the new world. On this slide, I just listed a few problems everyone is basically dealing on a daily basis. Everyone is IT. And the consequences of those problems are that, yeah, basically we are missing visibility into what's going on in our networks and infrastructures. We are severely lacking the people needed to address those problems, and obviously we are severely lacking the money for that. In the end, we have the IT departments which are frustrated, overworked, and universally hated by everyone else in the company. So what has been done in the recent years to change the tables, to turn the tables? Obviously, since the businesses are now increasingly digitalized, agile, flexible, they have to adapt to new challenges on a daily basis. They have to embrace new technologies. Here are the key expectations every business has from the IT departments. They need visibility, and not just in the IT focus, not just which bytes are flowing across the networks, but really what's going on, what are the new assets, what are the new challenges, what are the new problems, and what are the numbers which could be reported to the upper level, especially in regards to compliance. The IT has to provide the utmost agility, which can only work out if IT works hand in hand and collaborates with the business units all the time. And of course, it's all about security, because we are talking about security today. And this security policies, it has to be policy-driven, it has to be strongly focused on risk management, because this is how businesses think about security. And it has to be smart, automated, to ensure that every problem can be addressed in real time. So in a sense, modern IT security can be summarized to these three terms. It has to be driven by business requirements. It has to be an integral part of every business process. It has to involve every party within the company, and not just within the IT department or development and operations, but literally everyone. And it has to be intelligent. Unfortunately, for many people in and out of IT, cybersecurity still remains some kind of product, a thing which you buy once, put on a shelf, and it works on its own. I usually call it a cybersecurity cargo cult. After that very kind of known phenomenon observed in the Pacific Islands during the World War II, where the natives were building airports out of straw and wood, hoping that it will attract the magic planes bringing the cargo, the goods for them. And in a sense, we still observe this culture in the modern enterprises, and of course it has to be addressed, it has to be changed. And security culture is something which does not just pop up, it has to be worked out from both ends. On one hand, it's literally about everyone's awareness. Everyone has to be a part of the culture. On the other hand, it has to be leadership driven, and it has to be governed and controlled appropriately. It relies on things which were already discussed in the earlier presentations today, or on clear policies, on very well-trained incident response procedures, training for employees, and kind of the real-world training, not just e-learning, where you click some checkboxes and you are done in the end. And it has to be a continuous process. It has to involve all aspects of security, starting from physical things. Don't leave your USB sticks around and don't pick up someone else's ones. You have to be extremely agile against phishing and fraud. You have to be constantly updated on the most recent regulations regarding privacy and data protection. And for developers, it basically boils down to a thing which is called DevSecOps, and which I will address a little bit later. But more importantly, it has to be engaging, otherwise it will never work. So what is DevSecOps? Obviously, it's like DevOps plus security. Whereas when we are talking about DevOps, we are usually talking about kind of automating the whole process of software delivery, from coding to building, testing, integration, deployment, and daily operations. DevSecOps adds another aspect of that. So where DevOps is seen as infrastructure as code, where everything is configured and versioned, and every change is tracked, and everything is automated with regards to what's called continuous integration process. DevSecOps adds security as code, where exactly the same principles have to be applied to security. So we are no longer talking about security tools as add-ons. It's not about firewalls or antiviruses. It's really about making our security the same integral part of the whole process. And of course, it relies on collaboration. While talking about DevSecOps, one cannot really avoid talking about another acronym, which is DataOps. For many, kind of DevSecOps is limited to the actual development, the coding, whereas in the end, the whole reason that coding happens is about data, is about collecting data, sharing data, modifying data, and then securing the data. And DataOps, it kind of introduces the same approach towards data management. Originally, it was created by the guys from the data analytics business, but it can very well be applied, I mean, the same principles apply to development and security as well. Basically, it's all about automating access to data, regardless whether it's about a data analyst who needs to run some business intelligence research on a customer data, or a developer who needs to extend a business application, or testers, or just some sharing of data with third parties. So as soon as we have GDPR and other regulations which apply to this kind of data, they introduce massive friction. They say that it may take up to 1 week for developers to get a fully sanctioned and cleared and authorized copy of a production database in a highly secure environment. And of course, just like we have shadow IT, we will have shadow data ops, where they will just steal or whatever, abuse the regulations. And there are some interesting technical developments in this area happening now. And one I would like to mention is data virtualization, which relies heavily on automating the whole data delivery and data integration process with a very simple idea that instead of getting a copy of a database, you are supposed to actually get access to the original, which isn't original after all. Basically, you get a virtual snapshot of the data, which is on one hand live and may even be updated when the original data is updated, but it's actually automatically verified, cleaned, anonymized, whatever you name it, with all the security and compliance policies applied, delivered straight into the hand of the data consumer, automated, safe. Again, I'm not going to dive into technical details for the reasons of time. And let's kind of jump directly to the title of the presentation. Well, yes, APIs, containers, microservices. I really don't think I have to explain the meaning of each of these three acronyms. But when I was given this title as a kind of recommendation for this presentation, so like well, APIs and containers equals microservices, basically. So what's there to discuss? That's the whole point, that every time you add something up, you also add the risks and threats and other challenges. So again, we will start with APIs. APIs are, the API economy has been there for a decade, probably. For some companies, APIs have become not just the way to automate their processes or optimize some data exchange with third parties. It really became their core competence and the main source of income, be it some weather prediction service or even Facebook and Google and Uber and any other companies which basically rely on APIs to do their daily business. The problem in that APIs, and especially REST APIs, are great for developers, especially for lazy developers. They are simple, they are ad hoc mostly, still for many use cases, though nobody even thinks about the whole security and protection of those APIs. Well, yeah, 5 years ago, I started kind of tracking this area, and about 2.5 years ago, we have published a leadership compass, as we call it, a multi-vendor report on API management and security solutions. And there was really one company in the whole world which called themselves an API security vendor. Now I am working on an update of the document, and I already have found 5, which is nearly not enough still, but still a great positive improvement. And I have even met one company who claims to be API security analytics company. So it's machine learning thrown into it. Now on this slide, I've just summarized all the aspects of threats and challenges you have to think about when publishing an API. And definitely we are not going to dive deep into that. Some of those will be covered by other speakers in this presentation. But basically my message here is that API security is pretty damn difficult, and nobody is thinking about it. And at best, they would start thinking about it after the API is compromised. And again, security by design principle applies to APIs just as well as every other software development area. So this is just, again, without diving into details much, an example of the typical approach to API security now. Basically, you have your APIs somewhere, be it a backend or microservice or third-party interface, and you bolt another security layer on top. When one typically thinks about an API gateway, there is a lot of these products on the market. It's all about billing and monetizing and quotas, and at best about access controls through API keys. As I mentioned, a proper security gateway has to implement all of those. It has to protect from external threats, internal threats, and again, access control will be covered in the next presentation. Another popular buzzwords are containers. Containers are awesome because they are portable, they are efficient, and finally, they are standardized enough for us. I'm still saying us because I used to be a developer for years myself. For us developers to be able to write once and run everywhere. Remember, Java was using this slogan something like 20 years ago. Well, 20 years later, we have containers, which are almost there. So no wonder that containers, Docker, Kubernetes is such a rage for everyone, for every developer here. There are companies who are basically using those terms as marketing buzzwords, Just like 10 years ago, a company would say, we are now cloud native, because it's awesome. Some companies would say, we are now container native. So what? But apparently, for some marketing people, this word alone sounds, it's awesome. Again, when one is talking about containers, we have a lot of offers from companies around the world, big and small, cloud native or on-prem or hybrid, offering you fully managed, fully automated, totally intelligent, and of course absolutely high performance container infrastructures, but nobody is talking about security. And on this slide, I've listed, again, just a short selection of things one have to deal with when securing their container infrastructures. So obviously, containers run on a physical server somewhere, so that server has to be protected. Containers are built from operating system images, like Linux. Those images have to be protected. They have to be hardened, secured, validated that they have not been compromised during some stage of the development and integration process. And of course, the actual applications which are running on those containers have to be secured in the traditional way. So basically, on the left side of this slide, you have the same problems we have in the traditional application development and operations, but they apply to container infrastructures just as well. On the right side, I've listed a few more problems which are more or less relevant for containers on top of the common ones. So obviously, you have to protect all the publicly facing interfaces. We are coming back to the whole API security scope. Remember that huge diagram on the previous slide. We have to remember that containers run in they are much less isolated from each other than virtual machines. So there is this whole container breakout problem which has to be addressed specifically, where one container can be maliciously modifying, for example, the image of the other one. We have resource hogging. Again, it can be a typical problem of not being able to cope with the load, or it can be a malicious application just eating up all the available resources. It still has to be monitored for all the security and compliance issues, like every other infrastructure. And last but not least, this whole part of the CI/CD, or the continuous integration and development chain, which is now expanded towards integrating containers, has to be secured as well. And on the right side, I've just included a screenshot from a recent article. Aeroflot, the Russian airlines, they are probably one of the biggest companies in Russia, are kind of heavily invested in containers. Their whole public-facing interfaces are fully containerized. And I assume, or at least if you believe their claims, they are highly secured, and everything was done according to the proper best practices, but unfortunately they have forgot to secure the development copies of their container images. And as soon as some hacker managed to compromise the Docker registry, they immediately had access to the whole source codes, interface specifications, who knows, maybe even data. Well, unfortunately, there is no GDPR in Russia yet, so we don't know how many customers were involved, but you can never exclude that possibility. Excuse me. What can be done? What are some high-level recommendations regarding container security? Again, just like every other aspect of information security, there is no tool which can be called turnkey out-of-the-box container security tool. It has to be a part of a layered existing security infrastructure. And like every other aspect of cybersecurity, it has to begin with full visibility. You have to know what you are supposed to protect. On every layer of this whole container stack, all the way all the way down, from the bare metal up to the actual application has to be hardened separately. And you'll probably need experts, separate experts for each of those layers. And of course, all the other security technologies which are being discussed nowadays, and probably even by some other speakers during this conference. Microsegmentation, least privilege enforcement, security gateways I already mentioned, real-time security intelligence, another hot topic. That's where all this AI and machine learning is hiding. And of course, last but not least, you have to remember that about the human factor. We are the weakest link. The developers are lazy and negligent, and unless you enforce your security through and through, they will always find a way to compromise your application. And here we are finally coming to microservices. So again, just as an illustration, microservices are basically, or at least now when you're looking at the marketing literature, it basically boils down to containers plus APIs. Someone is maybe mentioning serverless services like Amazon Lambda, but for most it's just containers and APIs. So when you're thinking about microservices security, again it boils down to combining API security, which is pretty damn complicated, as I mentioned, with container security, which is again basically covering all the aspects of traditional security with a twist on top. And you end up with a seriously complicated mesh of additional services which have to be integrated as deeply as possible into your existing application infrastructure. So on this slide, each kind of blue part may be an API micro gateway or an additional like security microservice, or maybe a microservice antivirus or microservice firewall, basically you name it. And of course the market responds eagerly. Everyone wants to sell you micro firewalls and micro web application firewalls and micro you name it. But basically it boils down to, again, it boils down to increasing complexity, further complications of the need to integrate with different platforms which have different management interfaces. Again, access management, identity federation is a huge topic on its own. I am not even going to dive into that direction myself. And again, it's all about business aspects. You need to have governance. You need to have a strong audit trail. You need to think about all those things as well. So on this slide, basically, I just thrown together a number of boxes. What are the key areas for securing microservices? And none of it is actually anything specific to microservices only. It's all the traditional aspects of information security we have to deal, starting from the low-level infrastructure all the way to governance and compliance. And yet, probably each box with its own twist and an additional level of complexity. And this is it, basically. So we had this development from traditional IT, which had no idea about security at all. Then we came to DevOps, which kind of started thinking about automation and automation as one way to improve security. The next step is obviously DevSecOps, where we are heading now, where security is going to become the integral part of this development and operation process. And somewhere in the future, nobody knows what kind of crazy part they will add to the acronym. I just thrown in the DevSecOps. I really hope someone else comes up with a better name for that. And basically, that's it for my presentation today. Thanks a lot, and we do have a couple of minutes left for any questions.